Hello, and you're joining us today for a rather long MDAR training video. This time we're going to be looking at the Odroid C2 and going to be running DietPi, openHAB and Node-RED onto it and adding, of course, the Velbus binding. So, lock yourself in. This is a long one. So we started off with an Odroid C2 16 gig kit. It comes very easily. The motherboard's in a case like this. It comes with an eMCC card preloaded with Ubuntu Linux, and you can get a little eMCC to SD card adapter, and I use an SD to USB adapter just like this. The Odroid do sell an eMCC direct to USB if you want it, but the three of these seem to work very well together. It also comes with a case in black or clear, and there's an RTC card on there as well. Everything you could possibly need to get yourself started. Oh, and there's a power supply with EU or UK connections. So let's assemble the eMCC into the adapter, and that into the USB card, that into the USB adapter, and get it into the computer. So if you go to dietpi.com and the download section, make a note of the username and password there, and then choose your SBC of choice. We're using an Odroid and a C2, so we need the stable image for that. It downloads and unpacks to about 500 meg, and it'll fit quite happily on the 16 gig card and leave you plenty of room for storage. So unpack it with your decompression software, and if you're interested, the hash information is in there as well, so you can confirm the download's valid. And you'll need a piece of software to flash that to your MCC card. I use Etcher by Balin, the link's in the PDF document. It should automatically detect the MCC card and just point it at the image. And don't go too far, because this took roughly 2 minutes on my computer to flash and validate. It'll unmount the card automatically for you. There you go, there's confirmation. And you can just whip that out of the machine and go back to the other side of the bench, and we can start assembling the unit. So I've taken the eMCC card off the adapter and I've just put it to one side. We don't need that unless you're going to make some snapshot images later. And it's just a matter of putting it all together, which is a nice straightforward process, thankfully. The SBC motherboard, it comes out like that. And it's nice, bit compact, not for my big fingers though. If you look on the back of the eMCC card, you'll see a small burgundy strip. Now if you remove that, there's a self-adhesive sticky pad on the back which will hold it in place. If you intend to be making regular snapshots, I probably wouldn't bother, but it works very well. And as you can see on the back of the card, there's a nice little outline there for exactly where to put the eMCC. And line it up gently and you'll feel it positively snap in place. That's it, that's that bit done. This jumper here is the only interesting thing. It changes this connector, so that's full-time power, and that's the OTG card, but if you leave that jumper in place, it means the micro USB is only for power. So I always whip that out and apply power from the DC plug, and I'm free to use the OTG. So the RTC card goes in and connects to pin 1, as shown there. Just gently insert it, just like this. There you go. And there is a normal little piece of plastic there which isolates the battery, so just remove that and that's activated. Next thing, of course, is to assemble it into the case with the 4 screws. You don't need to see me doing this in real time, so let's speed it up a bit. 2 screws hold the motherboard onto the bottom half of the case. Case just snaps together. And then there's 2 screws which hold the 2 halves together. Be careful when taking them apart, they're a good fit. So to get this powered up, I'm going to need a LAN connection. I've got a USB connection into my Velbus rig, so when we set up VelServ in a moment, and it just needs 5 volt power. So I'm not using the supplied power supply, I've got 5 volts coming off my demo rig, so just power that up, and you should set a red light straight away, bottom right hand corner, and then there's a flashing blue light next to it, which we'll see in a second. There you go, which just is a heartbeat LED to tell you the board's alive and well. You can power the board down, and the red light will remain on, but obviously the blue light will go off. So I always use PuTTY to connect to an SSH session, but you're free to use the terminals if you prefer. PuTTY can be downloaded here. Type in the IP address of the board. Log in with the username root and the password of DietPi. It will prompt you to change that password the first time you go in, and it'll also do a full software update. So DietPi software is the configuration, and we're going to search for software, and we want node-red, and what pops up, click the spacebar to activate it. Search again for Java, and OK, and the spacebar to select it, and OK that. If you want to go through these other settings, you can change the SSH server, you can add a file server, Samba if you want to be using VSC later on. I don't, but it's entirely up to you. And then there's an option there to change the web server should any other software need it, but don't worry about that. So the thing to do is to scroll down to the bottom to highlight Install and tab to OK, then OK that screen. And I've speeded this bit up. It takes about 3 or 4 minutes. I did on my connection anyway. 3 or 4 minutes for this to all download and configure. And when that's done, it'll simply prompt you that it's going to reboot. There you go, reboot. Now, these DietPis, not the fastest thing in the world to reboot. I mean, I've seen sometimes 20 seconds, maybe 30 seconds are needed before it's ready again. So by the time I've called up a PuTTY session, typed in the IP address, it's just about ready. Just like this. There you are. So root and DietPi. And in you go. So that's node-red running and Java. So we'll just check by typing systemctl space status space node-red. And that'll give us the systemd status report. If I can spell it. There you go. All happily running and prompting to change encryption. And if you want to know the Java version that's running, just Java space -version, and that'll show you that there. There's a link in the document for downloading OpenHAB, and it takes you straight to this page, and we can do the package repository installation. So first of all, you need to grab the repository key, so copy that, and then nice little shift and insert will pop that onto the terminal. Press enter. It takes a few seconds just to pull down the key. Next thing to do is to make sure we've got the apt transport loaded. It probably is, but always good to check. So copy that, shift insert to drop that into the terminal. Et voila. And the next thing to do is to decide which version of OpenHAB you want to run. Now, I always go for the stable release, theory being it's nice and stable, and people have already done all the hard work of checking that it's okay. If you're feeling brave and you want to help with the testing, by all means use one of the other ones. Again, shift and insert that, echo that in, and the next thing to do is to simply install OpenHAB. So we need to update all the repositories, and that's done with the apt-get update command, which you can see there. So just copy that and paste that into the terminal. That'll go through the quick thing and update all the repositories, just confirm access to everything. And the next thing is the fun one. So we type in apt-get install openHAB2 and press enter. And that's it. It's running roughly 70, 80-ish meg at the moment. That's reasonably close to real time. Now, the instructions are on. It hasn't started OpenHAB and it hasn't enabled it. So if you want to enable it to start at boot, copy that line there and that shift delete to copy that out. And shift insert or paste it back in again. And the next thing you want to do is copy that next line. There you go. So that's all set to start at boot. I'm not going to start OpenHAB right now, but when you do want to start it, you can either reboot the machine or you can copy this other line that says systemctl start OpenHAB. Right, but before we do any more, we want to install VelServ so that we can get our USB link into a TCP connection. So either look in the PDF or go to the Velbus website and grab this command and paste it into your terminal. But first of all, I'm going to change folders so it's all kept together. I go to the var lib openHAB folder. And shift insert and enter. That pulls it down, and then sh space velserv-setup.sh. Brace yourself, this will happen really quick. It downloads a new one, double checks you've got the right build essentials loaded, compiles it, and sets it up as a service file and gets it running, just like that. So the next thing to do is the latest Velbus binding from Cedric. So either go to the PDF or to the Velbus forum and grab the next command. That's another wget, and it's the update Velbus jar. Copy that, and you can paste it as is if you wish, or if you want to run a bleeding edge version, you can just append that file with -dev.sh, and that'll download anything that Cedric's working on that I haven't double checked. So that's it. Then just sh and run that script, and that's it. So we can start openHAB by issuing the command systemctl space start space openHAB2, and if you want to see how it's getting on, you can replace start with status. Doesn't tell you a lot, but it might give you some hints if ever anything goes wrong. So the thing to do, jump onto a web browser and go to the IP address of the machine and port 8080. And you'll eventually, if you keep refreshing it, you will eventually get this screen pop up with the loading options, which looks like this, and click on standard, and then that'll download the configuration for a standard installation of openHAB. I've seen some machines take 20 minutes, C2 about 60 seconds. Eventually it'll refresh and you get the paper UI. And one thing left to do is to add the serial binding to enable the Velbus binding. So down to add-ons and bindings, just type in serial. You get a couple of options, and we want the version 1 serial binding. Takes a minute, minute and a half to install, or quicker. And that's it. So I would advise a quick restart just to get everything in order. So you can issue that systemctl restart openHAB2 command. Takes a few seconds to shut down openHAB and restart it. It's a very graceful way of doing it. So go back to a browser and refresh the screen. And depending on what it is doing or what it was doing, you may get this again, or you may get straight to the start menu. But if you want to know what's going on, you can always issue this command to have a look at the openHAB log. And it gives you a nice blow-by-blow account of what's happening within openHAB. It's a nice way of spotting errors and seeing whether files have been accepted correctly. We're going to use this quite a bit in the next little while. So there we are. There's our HAB panel and paper UI. So into paper UI, and we want to add a Velbus bridge. So into the inbox, and that nice blue circle with the square, Velbus binding, on the top of the list, the Velbus network bridge. Now I discovered a trick. If you change the thing ID, if you ever have to completely rebuild your system, it'll use this same thing ID. Control just means which tab it's going to put it on control, and then to give it an IP address. So we're going to use the loopback of 127.0.0.1, and the port is 6000. If you open this information at the bottom, you can change the interval in which it updates the time on the Velbus bus, and you can also set the amount of time for reconnection detection. That's it. Click the tape, and that's it. That's your Velbus bridge added. Nothing else to do. So the thing I suppose we want to do really is see whether that's working and whether we can grab our Velbus modules. So click on the plus, click on Velbus binding, and it'll start scanning your network for devices. Now the model I'm connected to has only got 6 modules in it, so they shouldn't take very long to populate the inbox. There you go, that's all 6 of them. And we'll start with the relay pack, so just click on the tick, and give it a friendly name, whatever works for you. Obviously, you could have some that are controlling heating, some are lighting, all sorts of things. So just give it something that makes sense to you, and then you can show the thing. Now, part of the binding is to read the channel names, so it makes life a lot easier. So if you've configured them properly in VelBus Link, the names will appear there. Now, there is a virtual channel with most of the relay packs, so we're going to use this as an example. So just link it to something in Paper UI. And the top one there is the machine name, and then what we're typing in here is the human readable name. So we're going to call it VMB4RYLD channel 5. We'll call it an Outlook, just changes the icon. And that's it, that's linked. Now you can also edit the thing and change the location of it, just makes life a bit easier with the control in Paper. And if you want to, you can rename the channels within OpenHAB using that section. So if you go to Control and go to the New tab, there is a switch for our new item we've created, and you're switching it on and off. But because that's a virtual relay, nothing's happening in the real world. So let's go back to the thing, and we'll add some other controls. So let's pick this one here, a lighting relay, and we'll call it Office A Lighting. This is left over from about 8 years ago. I still haven't reprogrammed that module. And that's it. We now have an item linked, and if we go back to the control, and there's the model in the preview, and you can see when we click the switch, that light is going on and off. That's it. It's that simple. You've now created a link between OpenHAB and a VelBus model. Obviously, the same thing applies to other protocols. I just don't have much to do with them. But Paper UI is not the only way to create items. I've discovered after a couple of years of working with OpenHAB that it's actually really easy to do the text-based ones. So I've created one generic items file which has everything you could possibly need at the moment to do with OpenHAB and VelBus. And I've also added Google Assistant and Alexa metadata tagging in there as well. So because we're dealing with a relay, we'll just copy this one section here into a new file, just like that. Now, this is just one method of doing this. There are lots and lots of others, and other people have different ways. But let's run through what I'm doing here to explain it. So go back to Paper UI and just click on one of those double boxes to copy that piece of information, and we're going to paste it in to the channel name. So the trick in Notepad++ is to hold down the Alt key while you drag over the text you want, and then paste in what you've just copied, and then just tweak those last digits so that it all makes sense and each line is unique. So VelBus is the binding. This is the module type. This is the bridge that we're using to get to it. This is the address of the module, and then the last couple of digits are always the unique part of that thing. As you can see, we've got 5 channels on a 4-channel relay pack. And then after that is the Google Assistant. So the first half is the machine name. This second half here is the human readable name. So just edit that to make sense to you. I'm not saying I'm dull, but I'm going to type some pretty dull words in here. You can have whatever you like within these speech marks. This is what will appear in HAB panel, or I think basic UI as well. I don't use that, but and then the section on the left hand side, hold on, we'll get to that in a moment. There we go. Right, the section on the left-hand side is machine readable, so you won't don't use any odd characters, don't put any spaces in there, and make every single one unique. Now, to enable these lines, get rid of those double slashes and save the file wherever you like, however you like. It's entirely up to you. I'm going to be dull and call it demo4ry. And then it's a matter of copying that into the Odroid. You can either copy and paste that into a putty session using Nano, Or I use a piece of software called WinSCP, which is a secure FTP connection into the box. It's just one method. There are many, many others. You're welcome to do whatever you want. So we need to create a new site, and it's the IP address of the machine. And because I haven't set up any other users or passwords, we're going to use root and DietPi. I would advise creating a new user and setting passwords and changing the root password, but that's a different thing. So we need to navigate to the etc folder and find the openHAB2 folder and then the items folder. And it's just simply a matter of dragging and dropping that newly created file, which I store in some bizarre location. It's only when I narrate these things I realise how weird my housekeeping is. So drag and drop it onto there, and that's up. And if you go back to the web browser and refresh the page, you'll see that all those items have now been added to our thing. And you can see there's the item we created in PaperUI, and there's the item we created in the text file. You can't add metadata using PaperUIs, which is why I've had to learn the text way so that we can make use of the Google and Alexa metadata. So if you go back to Control and the right tab, there you'll see all of the items we've created for this particular relay pack. So if I choose that lighting channel, there we go, that's the two items switching, and there's the real world light coming on, and there's the one next to it, this is channel 4. And you can see by operating these, we're getting full control of the Velbus hardware. So it's just a matter of rinsing, repeating that process for all the assets you want to pull into openHAB from the inbox. So I've got another 5 on this demo model. I'm not going to do them now. That's for another video. And I'll go through explaining what each module is and what items it needs and how they interact with everything. And essentially, that's it. Rinse and repeat. But that's not where it ends. This is just the start of openHAB. So let's create a rule and start doing something fun with it. So we're going to go into a nano. I'm actually going to type the rule out as we go to show it. So what we need is a unique name for the rule. It needs to have a when statement. On this occasion, we're looking for anything to do with that channel 3, whatever it changes. And then we're going to do something. We're going to ignore this if statement for a second. We'll come back to that later. We'll add in one command. We're simply going to say, when channel 3 changes, we simply want to push that state into channel 4. And it's done by simply adding this line here. So we start with the name of the item we're talking to, send command, open brackets, and then what we want to send it. And on this occasion, we're not sending an explicit command. We're grabbing the state of something else and injecting it into it. So it acts as a follow, if you like. So just to recap, we're monitoring channel 3, and we're going to inject channel 3 state into channel 4. So Control X to exit out of that, and yes, and just use this tail command to see that it's loaded. Yep, loaded model, that's cool. Flip back, and if we go back to the control and to the demo rig, you'll see that when we click on channel 3, channel 4 now comes on with it. We can interact with channel 4 independently, but channel 3 will always send its command or its state into channel 4. But what about something else? So let's flip back to that rule, and we'll do something interesting to do with that virtual channel we spoke about earlier. So again, nano that. What we're going to do is simply go down to the bottom of the file, and we're going to change the state that it queries. So if we go right down to the bottom there, and where it says channel 3, we'll change that to channel 5. And now what will happen is every time channel 3 changes, it'll query the state of channel 5 and inject that into channel 4. So Control X to save it. And that's back in. Right, so now channel 3 gets triggered and not a lot happens. We can control them what looks like independently. But if we switch on channel 5, we can see that channel 3 sends the state of channel 5 into channel 4. And that's on any change that happens. So that any change of channel 3 triggers the connection between channel 5 and channel 4. There you go. But maybe that's not what we want. So let's go back to that rule, and we're going to activate that if statement now. So we're going to comment out that one command, and we're going to remove the comments from this one, and then I'll talk you through what this if statement does. Okay, so we have the rule, we have the thing we're watching to trigger the rule, and then we come down and we cut to the if statement, and we're saying if channel 3 state becomes off, what we want to do is send an off command to both channel 3 and channel 4. Except if it's not off, we want to send the state of channel 5 into channel 4. So it's almost the same as the previous rule, except we've added a condition that when channel 3 goes off, everything's switched off. So flip back to the browser, and channel 3, there you go, appears to be doing nothing else. But if we put on channel 5, and then switch on channel 3, you'll see it sends channel 5 state to channel 4. But then when you switch it off, everything goes off. So that's it. That's a nice simple little rule. You can obviously add numbers and change things. So go in and just delete that rule before we go to Node-RED, and we'll create the same thing in a different way. But first of all, we need to add a link on our dashboard, and that's done by changing or updating the dashboard.cfg file within OpenHAB. Again, there's a link in the PDF for this. There's the dashboard one. If you look at it, each link has 3 sections. There's a name, there's a URL, and there's an image file. So all we need to do is drag that into the services folder, and that activates it. And if we flip back to the server, there's our 2 extra ones. So just to show that's working, we're going to click on Velbus to show you the Velbus website. Et voila, and back. And then we'll click on Node-RED, and that will take you to your instance of Node-RED. So before we go any further, we need to add OpenHAB into Node-RED for the first time. So what we'll do is we'll get a better layout. So let's get Node-RED up there and Paper UI up on the side. And then we can see what everything's doing at the same time. So let's add OpenHAB to Node-RED. At the moment, we've got all the other nodes loaded, as you can see, which come standard with Node-RED. All grouped nicely. We just need the specific OpenHAB. So go down to the palette manager, click on install and type in OpenHAB. There's the options. My personal favorite is this one here, which was updated 4 months ago. Feel free to use the other ones. It's entirely up to you. As I keep saying to everybody, it's your system, run it your way. There you go. So that's the required nodes all installed. And if you scroll down to the bottom of the node palette, there they are. So let's drag an in node onto the flow and double click it to edit it. And what we do need to do is add a controller. So click on the pen there, give your controller a name. I'm going to call it demo because I'm dull, and then I'm going to use the loopback. And there you go. Now, there's it populated already. So we just want to click on channel 3. And if I deploy that, within a couple of seconds, we'll get the state shown in the bottom there. Just to zoom in to make it like a bit easier. And there you go. So we can see that that is off. And if we go over to Paper UI and control it, we can see it's happening in the real world and Node-RED is following the state. So how do we inject that state into channel 4 to recreate that DSL rule? So we need a Node-RED out node. Again, drag that in, double click it to edit it. Or if you're on a tablet, click and hold and choose edit from the radial. The same controller, and this time we select channel 4 and we need to tell it we want to send an item command. and we simply drag from the top outlet into the out node. The bottom one contains previous states and all wonderful bits of information that you don't need right now. Deploy it. You can either choose full or partial, entirely up to you. And if we go back to Paper UI, we can see we click on channel 3 and channel 4 is following the state, as you can see on the node red and in the real world there. And again, you can control channel 4 independently, and channel 3 will just update its state. Now, what about if you wanted to add a delay between one event and another? In a DSL rule, if for a very, very, very short delay, you might use a thread sleep, but it's bad practice because you're putting a thread to sleep. So, and there's timers, but I really don't understand those. The easiest way in node red is to drop a delay node in line, and we're going to set a 2-second delay now. And deploy that. And now what's going to happen is it's going to take 2 seconds between switching something on. You can see the timer triggered, and then it'll inject that state into the next channel. Just delays the payload. So what about channel 5? How do we recreate that same conditioning that we did with the DSL rule in node red? We simply drop a openHAB get node in the path, and we're going to call this channel 5. And we'll select the same controller and channel 5. We're going to query channel 5 state in this flow. Now, the only thing to be aware of, it's an idiosyncrasy of node red, is the get commands put that state onto payload.state rather than the main payload. So we need to use the change node, drop that over that line, and it's simply a matter of setting the payload to message payload.state. And we'll give that a semi-useful name to make sense. So we're moving the payload from payload.state to payload. Deploy that, and what we do is we click on channel 3, it waits 2 seconds, queries channel 5, and pushes channel 5 state into channel 4. So nothing happening there because channel 5 was off. Let's switch on channel 5 and switch off channel 3, waits 2 seconds, and then moves channel 5 state into channel 4. That simple. So that's basically, we've replicated what we did in DSL in node red. So that's it. So thanks for watching this video. If you've got this far, then congratulations. Pause it, go and have yourself a cup of tea. One other little thing that I've tried, that I thought I might tag on to the end of this video, is I've bought a couple of screens for this C2 in case you're wanting a screen. First up is a 3.5-inch serial screen. I assume the buttons on the side use the GPIO input, so I'll have to play around with those to see what happens. But they're really easy to install. Take the RTC card off your C2 machine, and this header lines up with this header. So whip it round, put it up, try not to touch the screen, put a bit of pressure between the PCBs, and gently insert it. It comes with spacers and all sorts of things and a touch stylus, but to be honest, for my money, the screen's too small, and if you're not running a desktop environment, then you don't need touchscreen anyway. But it's just a matter of going into the Odroid C2 DietPi software configuration and telling it you've connected an Odroid screen. So there you can see it booting up. And that's because I've already made these configurations. So in a second, I'm going to show you what I've done to activate that screen. So start a putty session and log in. And the command you want is DietPi space software dash software. DietPi dash software. And choose config, the second option. And we're needing to just change the display settings. So just to show the various different configurations you can have, but we're not interested in that. We'll change the memory map. We need to switch off the HDMI. It's currently off as shown just there, and you can just use the up down arrows to change that and OK it. And we set this LCD screen, and it shows it's detected the Odroid screen there. And just click OK. It'll quickly run a routine to make sure it's got the right files, and that's it. You can OK out of that or exit out of that. If you OK, it'll go round and round if you just exit it. And what you can do is if you go down to Auto Start Options, the second from bottom option is where it calls an Auto Start script. And what I've done is I've edited that so it shows the OpenHAB log. So if you, again, shift and delete that reference file, exit out of that, exit out of that, exit out of all of that, and go back to a prompt, we can nano and shift insert to there. And you'll see there I've put some sleep commands in to wait for OpenHAB to come up and running. And then I've put a tail command in to show the OpenHAB log and the events log. And in the insert there, you can see that running. And I'm just waffling to fill the 3 minutes time, to be perfectly honest. I could have fast forwarded, but I like the sound of my own voice now. It will eventually after 3 minutes. There you go. So it should just about be ready. We'll zoom up and it'll briefly show us the OpenHAB log, and then it'll load the events log onto the screen. So if you want to put something in a cupboard and just be able to see at a glance what's happening, then this maybe is a solution for you. It's not that expensive and it works quite well. The optional case isn't great though, so you might want to consider building your own case. And there you go. So that's showing the OpenHAB events log. Now you can plug a keyboard in there and just press Ctrl-C to exit out of that, and it should prompt you to log in. But what I have got also is a 7-inch multi-point touchscreen that we're going to have a play with next. So we'll shut down this other machine and then I'll plug in this 7-inch one and then show you how to change the settings. So USB keyboard, power off -N, space -N. And then eventually it'll get to a point where it'll tell you that it has reached the shutdown point. Not entirely sure why it doesn't power down the screen, but it'll simply hold that state until you remove power. There you go, reached target shutdown. So you can pull the power from it, and it simply assemble the 7-inch screen as you'd expect, power, touch, and HDMI. Touch goes into the OTG, power from the USB connector. Another putty session in there, and we'll go to DietPi-software, and again, second option, and DietPi configure. This time we're going to enable the HDMI and make sure the resolution's set to the 7 UV and it's 1024 by 600. Change the memory allocations. We need to enable the HDMI. Select it, just showing there that it's current state. Click on OK, and it says current state is on, but obviously it won't be activated till a reboot. We need to disable the LCD screen, like that. There you go, exit out of that, and don't forget to change the auto start. On this occasion, I'm going to go to Chromium, option 11. And this prompts you for the URL that you want the Chromium to load. So I've just done the loop back to OpenHAB and given it root user. And exit out all of that. What I do want to do is edit the Chromium auto start, which is in there, that link's in there. And for some reason I couldn't get the DietPi to read the resolution, so I commented out those. Turns out I should have simply edited the dietpi.txt file at the bottom. So entirely up to you, whichever way you want to do it. I set them manually. I also added a 3-minute sleep in this script to account for OpenHAB starting. There's the thing, and then just leave the rest of it well alone. Oh, apart from these two lines here, these are new. They stop the that restore bubble that you can never quite get rid of. So reboot the machine. It takes obviously the 3 minutes for it to set up OpenHAB, and then you'll get Chromium as a standalone application in an X server with full touch support. So there we have our OpenHAB environment. And there's no back button available, so be very aware that the only way to get back is either if you build a link into your UI, or to reboot, or to exit out of that Chrome. So there you go. That's openHAB working. There's nothing much in this thing. It is a demo unit. I just mess around with it really. But just to show that it's working, it's supporting openHAB. A couple of selection widgets changing the value of an item. Thermostat widgets. It's not connected to the right demo. It's not connected to the right demo units. There's no valid data there, but the widgets are working perfectly well. So for the point of this exercise, it works. So there we go. That's the end of this video. At last, hurrah! You can go and have some tea now. So thank you very much for watching. Don't forget to subscribe to our channel if you haven't already. I'm trying to add loads more videos to make life a lot easier for everybody. So feel free to click on some of the links here. Have a look around the channel and see what else you've got. But on the whole, just enjoy your new openHAB setup.